are launching into lesson 31. We are going to see a lot of similarities between lesson 31 and lesson 29 and lesson 30. Lesson 31 is very, very similar. We're still dividing by decimals. But in lesson 31, we're going to estimate. We're going to use our estimation skills first. And then in the end, we are going to, I'm having a difficult time finding my words. We are going to compare our estimation to the final answer, and we want to make sure that they're reasonably close. If they're not reasonably close, then either let's check out our estimation or check out our final answer. Estimation is such an awesome tool to bring along with us. It's just that final logic step to see if our final answer is in the correct place value. So let's take a look at 39.36 divided by 0.96. We are going to rename this expression just as we did in lesson 30 as a fraction. Everyone watching this video, hopefully, I know my homeroom kids know that every single division expression can be rewritten as a fraction. Oh, there you go. Every single division expression can be rewritten as a fraction. Watch how easy it is. Instead of our division symbol, we use a fraction bar. So we're looking at 39.36 over 0.96. And just as we did in lesson 30, we're going to multiply this fraction as some fancy version of 1 so that we can shift these digits out of decimals and into whole numbers. What would I have to multiply 39.36 and 0.96 by so that each of these digits hopped over 2 place values to the left? Well, I would have to multiply them by 100, because when you multiply something by 100, it has 2 zeros, so each of these digits is going to hop 2 place values to the left. So and that works out perfectly. So we're going to multiply 39.36 by 100, and then 0.96 by 100. This is 100 over 100, which is equal to 1. I can show you that by thinking about this. 100 divided by 100 is equal to 1. This is just a fancy different version of 1. So we're not changing the value of this number. We're just shifting its version. We're shifting it out of decimal world and into whole number world. So 39.36 times 100 is going to result in 3,936. Pretty cool. Let's just check that out on the place value chart. I love to spend my time there. So we started with 39.36. We multiplied it by 100, and these digits hopped over 2 place values to the left, because when we multiply something by 100, all of the digits are going to shift 2 place values to the left. So you can see all those numbers hopped over there to 3,936. 0.96 multiplied by 100 is going to be 96. I'm not going to, so 0.96, you can see 2 hops for each of these digits is going to result, I'm just going to write it right here because I'm out of room, as 96 ones. So this is where I want you to do the estimation. Let's estimate, I don't want that equal sign there. Let's round these numbers. I'm going to change this equal sign to that wavy sort of estimation equal sign. 3,936 is pretty close to 4,000. I'm going to round 3,936 to 4,000, and then 96 is pretty close to 100. So what is 4,000 divided by 100? Think about it. 4,000 divided by 100 is going to be something that starts with a 4. What we ultimately need to think about is this number times 100 is equal to 4,000. If we want to think it algebraically, 4 times 1 is 4. What number times 100 is going to result in a number that has 3 zeros at the end of it? I think 40. Let's see if that works. 40 times 100 is going to be, well, 4 times 1 is 4, and then we have 1, 2, 3 zeros. Sweet. So we were just able to use our reasoning and understand that 4,000 divided by 100 is 40. So when we do the standard algorithm, our number is going to have to be pretty close to 40. So that's the estimation tool. I'm going to use our eraser and just make some room for the standard algorithm. I think that should be good. So again, our estimation, I'm going to put that right here. We are shooting for this to be pretty close to 40. Let's use Patriot and Loyalist colors. So now we're just going to do, okay, so we've estimated, now we're just going to do the standard algorithm, or at least what we consider to be the standard algorithm right now. So that looks like the same. I'm just going to do this in red though. 39.36. We're rewriting this expression as a fraction. So that's 39.36 over 0.96. We're still going to multiply that by 100 because we want to shift those digits out of decimals and into whole numbers. And a lot of this work is already done for us, which is wonderful. So we end up with 39.36 over 96. But now instead of rounding and estimating, we need to simplify 3,936 over 96 because I have never seen a more improper fraction. We can do this really, really easily by just doing some long division. Brush off your long division hats because we are going to get some practice with that here in lesson 31. So we're looking at 3,936 divided by 96. So I'm looking at 96 and 39. That's not going to work. So let's look at 393 divided into 96 equal groups. I'm going to use some estimation here. I'm going to think about 400 divided into 100 equal groups. I'm going to work on, let's start with 3 and see where that gets us. Oops, no, that's not right. This is Calamar's. We're looking at 96 times 3, not 393 times 3. So I'm trying to see what our good starting quotient, or the first digit in our quotient, would be. So we're looking at 96 times 3. 3 times 6 is 18. And then 9 times 3 is 27 plus 1 is 288 less than 393. It is. Is the difference between 393 and 288, though, is that going to be more than or less than 96? I'm just going to take a leap, and I'm just doing like some estimation in my head, and I'm thinking that we'll be okay, but let's see. So 3 times 96 is 288. We have 393, and we're taking 288 from it. We're looking for the difference here. So let's look at 13 minus 8. That is 5. And then I have 8 minus 8, which is 0. And then I have 3 minus 2, which is 1. Is 105, friends, less than 96? It is not. What does that tell me? Well, I'm not super excited that 105 is larger than 96, but now I'm able to realize that this 3 should not be a 3. And through the magic of Control Z, I can pretend that that 3 never happened. That 3, my friends, should be a 4. We can squeeze one more group of 96 into 393. Let's look at 96 times 4, and that I am very confident that that is going to be closer to where we need to be. 4 times 6 is 24. 4 times 9 is 36 plus 2 is 38. Okay, that looks actually much better. Okay, so 4 times 96 is 384. Okay. Let's find the difference between these two numbers. 13 minus 4 is 9. And, okay, good. Well, this is actually working out beautifully. So is 9 smaller than 96? Yes. We may proceed, and look at how beautiful this is, friends. Bring down the 6, and now I'm looking at 96 into 96. is 1. 1 times 96 is 96. Woohoo! We don't have a difference. And our final answer there is 41. Final versus our estimated in 40. I'm sorry, our estimated in blue is 40. And I would say these numbers are pretty darn close together. So I feel super, super confident with this as my final answer. A lot of moving parts here, friends, but we've been working on this fun stuff all week, and we've been working on this place value work all year long. So you have the tools that you need to be successful in this lesson. I'm so excited to practice this with you all tomorrow. I'm going to hand the pen over to my math friends, and they're going to do a few problems with you as well.
What lesson is it? Oh, yeah.
Lesson
30. Oh, gosh. 1. Okay. So, 532.2 divided by 0.4. So, first we have to estimate this to make it to give an estimate. And we're going to make 532 into 520, and 520 below that we're going to make it into a fraction 4, because you're able to do that and make it into a whole number, which equals 130. So that's our estimate. Done with that. And so now we have to make this into a fraction. So we're going to do 53.2 not over 0.4. And then now to make these fractions, or to make these decimals into normal numbers, we have to multiply it by some other fraction that's equivalent to 1 whole. And we're going to do 10 over 10. And then that's going to equal to 532 over 4, because if you do it on a place value chart, 10 moves the digits over this way by 1, so the decimal goes over here and the decimal goes over here. And then now we have to do 532 divided by 4. So let's go 532 divided by 4. So 4 goes into 5 once. I'm going to put 4 down here, and we have to subtract that, which is 1. Drop the 3. And 4 goes into 13. Let's see. 4, 8, 12. So it goes into 13 3 times. And 4 can't go all the way into 13, so it's going to be 12. Because 4 can go into 12. And then that's 1. And then we're going to drop the 2. And like I just said, 4 goes into 12 3 times. And then that's, which is 0. So the answer is going to be 133, and our estimate is very close to 133. It's only 3 off. And so that is a reasonable answer. Thank you.
I know. I forgot what this is called. It's, we're estimating. That's what it's called. Anyways, so we have 1.52 divided by 0.8. I think 1.52 is pretty close to 1.50. So bad. Divided by, now we're going to divide it by something that we're going to estimate right here, which I think 0.8 is really close to, 8 is close to 10, so let's do 1. Just like that. Okay, perfect. So now we're going to make this a fraction, because the division symbol is equal to a fraction bar. Okay, so our fraction right now that we have right now is 150 and then over 1.0. So now we're going to multiply it by some fancy fraction that is equal to 1. So, sorry, that just don't. It's equal to 1. And so we're going to make sure that, sorry, I forgot to put the decimal point here. So now we're going to do, let's see on our place value chart to see, you can use this if you want, a place value chart that we used a long time ago. So we have 1.50. We're going to see, I think, 2 spaces. So we're going to use 2 spaces. We're going to multiply it by 100 because look, now the decimal point is in front of it. So we're going to multiply by 100 over 100. Sorry. Which then equals, we're going to scooch it over there. So we know that this is 150 over, we know, well, that this is 10. So now we have to do, so now we have to see how many times 10 goes into 150, which is 1.5, which is also equal to 15 tenths, if you were wondering. Perfect. So that's our estimation, but just to make sure that it's correct, we are going to quickly go ahead and do the real problem. So we're just gonna do a couple lines right there. Okay, so we have 1.52 divided by 0.8. So again, we are going to do a fraction bar because, well, take a look up here. Anyways, so we have 1.52 over 0.8, and now we can multiply it by a fancy fraction. So we already know that we're doing 100 at the top, so that means 100 has to be our denominator. So this equals 152, and this equals 80. So now we have to do 152 divided by 80 to simplify. So we can't fit, why did I just do that? Okay, we can't fit 180 into 1. We can't fit into 15, but we can't fit into 152. So it only goes in there one time, because if we count by 80s, it's 80, 160, right? So we're doing this too. It only goes in there once. So minus 80, 2 minus 0 is 2, and then let's just make this real quick, and that, my friends, is 7, right here. So, and then we can't fit 80 into 72, so we're going to make a decimal point, put that up there. Sorry about this, this doesn't, I don't know, I'm very messy. We're going to bring this down, so now we have 720, 80 goes into 720, 9 times, so we have 1.9 right now. So 720 minus 720 is 0. So that means that 1.52 divided by 0.8 equals 1.9, which equals 19 tenths. And I think that these two are pretty close because, yeah, that's just how it works. It's only 4 away, so yeah, that's how you do this problem. Thank you guys for being awesome.